Whenever I ask the question, what makes a computer, I'm invariably given a series of items that are common to the computers we know. A mouse, a keyboard, monitor, case, or some form of storage device, be that a hard disk drive or a solid state drive. Are these actually the features that make a computer? If not, what are the components? That's what we're going to delve into. When we ask that question, it is usually this type of computer that people are picturing. This is a desktop computer, even though the case is a tower case, and you're more likely to put that case underneath your desk or to the side of it. Still called a desktop computer. We can see that this fits that definition. There's a mouse, a keyboard, a monitor, a case, and we can assume that inside that case there is a storage device, maybe a hard disk drive or a solid state drive. So this fits our definition. But is this true for all computers? Here's a laptop. Now we can see clearly that this laptop has a keyboard, a monitor, a case, and we again can assume that inside that case is some form of storage device. But there's no mouse. Yes, there is an item on the screen that we can move, but that's not called a mouse, that's called a pointer. The mouse is a physical item that you hold in your hand and you move. The laptop doesn't have a mouse. It has a trackpad or mouse pad. Yeah, it's got the word mouse in it, but it's not a mouse. So this does not quite fit our definition, but it's pretty close. Maybe we can just give a little latitude. Here we have two handheld devices, a tablet and a mobile phone. Both are very similar, that's why I've grouped them together. This is where we start to see things crumble, because not only is there no mouse, there's no pointer. The pointer doesn't exist anymore, it's a touch sensitive screen. There's also no keyboard. Yes, you can put up a virtual keyboard, but there's no physical keyboard here, and you could use it entirely without ever seeing a keyboard. The whole thing is a monitor, definitely got a case, and there's definitely storage, usually solid state. So it's got some of the features, but not all of them. Our definition is beginning to look a little bit shaky. For decades now, cars have had computers on board. These have monitored the engine, making sure the car runs effectively and efficiently. These haven't had cases, they've been a chip on the circuit board. If they had a case, if we classified something as a case, it would be the car itself. Most of these didn't even have monitors. Yes, they might turn on a small light to say your door's open or the engine's running badly, but the dials and everything else were controlled through other mechanisms. Modern cars now have display panels and allow you to choose your music or route find, have a lot more complex computers. So yes, they have a monitor, but they still don't have a case. They are built into the car itself. So cases are not something that we always see. So we can rule out case as one of our defining features. In the 1970s, a company called LJ Technical Systems produced a series of computers called the Emma and the Emma 2. These computers were used by students to learn how to code in hexadecimal for a processor called the 6502. None of that has to make much sense. The main thing is, this is a complete computer. It allowed you to run computer programs. Yet, there isn't a keyboard. Well, there is. The red buttons are the keyboard and the blue buttons are the keyboard, but you'll notice that they don't quite make sense. That's because the red keys are hexadecimal and the blue keys are control keys. This is not a keyboard in any sense that we recognise. There isn't a monitor. There is a display. Those grey rectangles you see above the keyboard, those are each a 7-segment display. It gives you very, very limited information about what is held in memory. It's not a monitor. Definitely no mouse. There is definitely no case, and there is no storage. The programs are held in memory, and only are held in memory while the computer is switched on. If you remove the power, all the memory is lost. Whatever you wrote is lost. You'd have to attach some form of storage device, and these days a tape recorder, and download the program onto a tape. So this is a complete computer without a mouse, without a keyboard, without a monitor, without a case, and without storage. But it is a training computer, so maybe that makes a difference. Well, it's still a computer, but it's an oddity. Maybe we can ignore it. Here's a BBC Microbit, or actually two of them, so you can see both sides of it. The BBC Microbit was again seen as a training computer and sent out a few years ago to all schools so the students had this computer. The one on the left hand side, you can see two buttons. That's what those little silver boxes with the black circle is. In the middle you've got some dashes, but those are actually LEDs, so that's a kind of display. On the other side you've just got the fundamental parts of the computer. There is no mouse, there is no keyboard, monitor, mouse or storage on this system, and yet this is a computer. Yes, it's a training computer, so yes, it falls under the same thing as the Emma 2, but this is still a computer. So the Emma 2 was not an oddity, it was a computer of its time, and it's still a computer, just as the computer in the car is a computer, just as the laptop or the tablet is a computer, or the computer in your microwave oven is a computer. So we can begin to agree that those characteristics that are commonly given when you say what makes a computer, those characteristics are not characteristics of a computer. Let's just look at one more example just to confirm that. This is a Raspberry Pi, originally seen as a training computer similar to the Emma 2 and as the Microbit, but it's being used for a lot more. I've known it used as a web server, I've known it used as a firewall, I've known it used when people have launched balloons to see the curvature of the earth, and all kind of things. It's a very complex computer, and this, as you can see, has no monitor, no mouse, and all the other characteristics. It is a fully fledged computer, quite powerful one, and yet it doesn't have those characteristics that commonly come up. So we can rest all those points and say those are clearly not the characteristics that makes a computer a computer. So what are the characteristics? So let's get to that now. This is known as the 3-box model, and it defines the essential parts that makes a computer a computer. A computer basically has to have 3 primary components. It has to have a processor, something that does all the work. The processor undertakes all the instructions, carries those out. It's the workhorse of the computer. Then a computer's got to have main memory. The processor can only process one instruction at a time. Main memory holds all of the instructions the computer needs, so that the processor can call the instruction it needs next and then carry it out. So the main memory holds all the instructions that the processor needs to execute. The computer needs a way of communicating with the outside world, so it needs some input-output ports, or what are known as I/O ports. That means that the computer can communicate, connect with items outside. What kind of items? Well, we could go for things like keyboard, mouse, monitor, storage. All of those items that we thought were part of the computer aren't. They connect to the computer through things called the I/O ports. So the I/O ports are essential to allow the computer to connect with the outside world, to get data in, to get the instructions in, and also to send data out. Connecting the processor, main memory, and I/O ports is the system bus. The system bus comprises of other parts. We can break that down into further details, but the system bus connects and allows the data to flow from all 3 of these components. The dashed line is the border, so that defines how the computer, what forms the computer, and the black shaded just indicates that that's a connection with the outside world. this is the 3-box model. It's theoretical. No computer looks like that. But let's have a look at some of the computers we've already talked about and see if they fit within this definition. The first 3 things we looked at was the desktop computer, the laptop, and the tablet mobile phone. Inside of all of these is something called the motherboard. Now the motherboard that you're seeing here is an old one that used to be in desktop computers, and they will look slightly different, but not massively so. And what we've got here is everything you need to be a computer. Here is the processor. In fact, this one's got an old processor resting in it. Normally you just see the socket for the processor. The motherboard has a socket that the processor goes into. This is the processor, so there's our first component. These slots are memory slots. This motherboard has some memory cards in there, but again, it's an area for you to plug in the memory cards. So we've got main memory here. Virtually everything else you can see are I/O ports, the ability for the computer to communicate with the outside world. So we've got our processor, main memory, and I/O ports. What about the system buses? Well, actually, that's what the motherboard is. The motherboard is a whole connection of wires connecting the processor, main memory, and I/O ports. That green board is the system buses. What about the other devices we've looked at? This is the EMMA 3. Again, this is a diagram which represents the EMMA 2, but it's identical to the original board. And the nice thing is, because it was an instructor's system, they're actually already labeled. Here's the processor, here's main memory, here are the I/O ports, here's the BBC Microbit. We can see on the right hand side the label marked processor that points towards the rectangle that is the processor. You'll notice there's nowhere on there that it says memory. That's because the main memory is actually part of the processor. It's integrated into the processor. That makes it more of a CPU, a central processing unit, but that's a different conversation. There are some extras added on there: compass, accelerometer, the BLE antennae and things like that. Those are normally devices that connect the I/O ports, but they wanted that integrated onto the microbit. But everything else is I/O ports. Everything there is an I/O port. And the Raspberry Pi, processor, main memory, and virtually everything else are I/O ports. So this fits with everything that we've been discussing. What makes a computer? The 3-box model helps us visualize those essential components: the processor, main memory, and I/O ports.